More limits. Well, not really at infinity. I don't know where infinity lives, the concept. But, yeah. So, to continue being completely obnoxious, I'm curious. Have I ever shown you this? This 1 over x? You ever checked this out before? Of course we have. Beating this dead horse as much as possible. So that limit as x tends towards infinity. Have that high to 0, right? And the limit as x tends towards negative infinity. That's got that high to positive. That's also 0, positive 0. Yeah, okay. We're good. We've seen this graph a few times. You're like, I think you got it by this point, huh? Got your 1 over x, what it looks like. But now we want to ask these questions. What's the limit as x tends to 0 from the positive side of 1 over x? What's that equal? Let's go back to this. Let's make sure we're there. Now, what's this concept? Where's this going? So we're saying that when our x values are getting closer and closer to 0, so they're going this way from the positive side. So it's just going to go to the line. So we watch it as to how it behaves as it gets closer and closer to our line, the y-axis. Or x equals 0. Y-axis, x equals 0, same things. But we want to know what's happening with the y. And clearly our y blows up to infinity as our x goes to 0. And remember that your limit is always what we're talking about with your y value. Where's your y value going? So this goes to positive infinity. Now if we were to take the limit as x tends towards 0 from the left-hand side, well, shoot, let's look at it. So that'd be saying taking our x's towards 0 from the left-hand side. So we're going this way at it. So as our x's are going to the left, where's the height going? The height's going down to negative infinity. It's approaching a vertical asymptote. Nothing can cross past a vertical asymptote. Nothing passes by a vertical asymptote. But yes, things can pass over a horizontal. We just don't have it. I showed you in examples in the past. And how many horizontal asymptotes do you think you could get? I think you could get 2. Challenge me on that one. Inverse tangent of x. Moving on. Mind if we graph these up real quick? Just a quick little graph. I was actually shocked myself by taking a calculus class and how little graphing I knew how to do. And I hear from many students that are like, yeah, we definitely need like a little bit of graphing review. We lose a lot of our skills, we don't use them. So who knows, maybe you took a semester off or something from math, or a year off. Whew, that's so tough to come back from. So let's graph this one real quick. And this one's pretty simple, just because, hey, don't let x equal what number? What number would that be? That'd be negative 2, right? If you plug in negative 2, that's muy malo. Don't do that. So that's saying, right here, boom, we can make ourselves a vertical asymptote. And nothing passes by a frickin' vertical asymptote, right? So x equals negative 2. That's where this little line is. It's right there at x equals negative 2 because we're not allowed to go there. So I wrote that in pink. So our graph, it's still going to look like our parent function. It's that 1 over x I just won't shut up about. It's the same picture, just shifted over. See, so since we know the picture of 1 over x, we're like, hey, dude, I see a number up top and an x down below. I'm like, hey, it's the same freaking picture. I just got to figure out where the damn asymptote is. And look, we just graphed it. Dope. It's no big deal. Let's go. Let's go. Granted, we're doing algebra, but in a second, I'm going to start asking you to do a little bit of the calculus through this. So we look at this next one. We're like, all right, we got to graph this up. So it's like, all right. Said something about where the denominator equals 0. So let's go find out where the denominator equals 0. Let's just solve. We're like, you can bring it over to one side and do this. Oops. Are you going to remember to hit it with a square root that you need your plus or minus? You're going to remember that each time? It's true. I typically just treat it as a difference of squares. It's x plus the square root of 3 times x minus the square root of 3. That's a difference of squares, telling me just use that zero product principle that x is equal to negative root 3 or x is equal to positive root 3. It makes it to where I can't brain fart. I can't accidentally forget. So this is saying that we have issues there. We have issues at root 3 and negative root 3. And you might be like, where is it? Watch, I'll show you where negative root 3 is. It's right here. Let me show you where positive root 3 is. It's right there. Cool. And then we graph. Now this one's going to require a little little bit more, but I'm just going to run through. I'm going to graph this thing up. I know it has a horizontal asymptote at y equals 0 because the degree of the bottom is bigger than the degree of the top. And I know it'd be positive if values were bigger than root 3. I mean, it'd have to be. And then the values, I don't know, they would have to do something else around here. I don't know, probably do a little something like this. I'm not exact on all the numbers, but I know it's going to be a little something like this. And then we're going to be a little something like this. Now, it's okay if you don't quite know how to graph this thing up. It's okay. I'm not putting any numbers in there. I'm being pretty mellow about everything. Oh, yeah, I know what that number is. I know what that number is, but that's fine. Cool. Yeah. We graphed. Cool. I'm sorry you had to watch graphing from algebra, but we got to have these fundamentals down. We got to have it. So let's go back and say, all right, now what is the limit as x tends towards infinity of 1 over x plus 2? There's our problem. F of x, right up there. And this one we're like, oh, it's going to 0. What's the limit as x tends to negative infinity of 1 over x plus 2? That's also going to 0. It's going towards that y, or the x-axis, or where y equals 0. Now let's look at the limit as x tends towards, let's go towards negative 2 from the left of 1 over x plus 2. So from the left, that would be from this direction, which is telling us we're going down to negative infinity. And if we went from the right, we see we're going from a different direction. It's now blowing up to positive infinity. Cool. Well, you'd get questions very similar like that to your g of x. So I would leave that as an exercise to you. If you wanted to play the games with the different ways you could write your limits and see whether they go to negative infinity and positive infinity, and notice that they still have the same idea. All of them are the same when you talk about the limit as x tends towards infinity. This is all going to be the same. Whether you're talking about g of x or f of x, they're both going to 0. Whether that's going to positive or negative, it makes no freaking difference because the degree of the bottom is larger than the degree of the top. All right, so there's just a little graphing, get you back into the mode, because I know these rational functions are weird as shit. So I will see you in the next one.